take derivative. What? E to the x. E to negative x, the derivative is negative e to negative x, and over 2. See, the derivative cosine is sine. What about tangent? Hyperbolic tangent of x, derivative is secant square, same thing as we had before. Hyperbolic secant square of x, cotangent hyperbolic x, derivative is cosecant hyperbolic square of x. Negative. Okay, more. Sine and what? Next one, sine, cosine, tangent, cotangent, secant. Secant of x derivative, secant derivative, the regular secant derivative is what? Secant is secant tangent, right? So secant x, tangent x, I think it's got a negative in front, let me check. Yes. And then cosecant derivative is negative, yeah, cosecant f times cotangent of x, the negative in front. Okay, how to prove this? Back to definition. Cosecant is 2 over e to the x, e to minus e to the negative x, and differentiate. You have the right hand side. Okay, now let's talk about the inverse. Inverse hyperbolic trig function. We have y equal to hyperbolic cosine of x. So the inverse function is going to be what? X is equal to hyperbolic cosine inverse of y. Is that right? So this is the inverse of this, and how do you write the inverse function? Let me see. Those two are the same. So the inverse of this function, I mean, is y equal to hyperbolic cosine inverse of x. This is the inverse of this. Okay. This is the original function. This is the inverse. Okay. This is my original function. This will be the inverse of that one right there. And of course, the inverse of sine, you're going to write this way: y equal to hyperbolic sine inverse of x, and cotangent inverse, tangent inverse, secant inverse, cosecant inverse. Nothing special. Okay. Now, talk about derivative. Oh, they give you the function for the inverse as well, so let me copy it on the board. So, sine hyperbolic inverse of x is actually equal to ln of 1 plus square root of x squared plus 1, where x is real numbers. Okay? And hyperbolic cosine inverse of x is going to be ln of 1 plus square root of, oh, it's not 1, x plus square root of what? X squared minus 1. X squared minus 1, of course, the condition for this is going to be x being greater than or equal to 1. To make sure that the quantity inside L is going to be positive. And tangent hyperbolic tangent inverse of x is going to be 1/2 ln of 1 plus x over 1 minus x. And I think we have relation to x is going to be between -1 and 1. So absolute value of x is going to be less than 1. Now, how do we prove that the sine inverse equal to this? And I claim that's the same thing that happened to cosine and tangent. Okay, so we want to prove something with inverse. We try to bring it back to our normal function. That's y equal to sine hyperbolic inverse of x, and that means x equal to hyperbolic sine of y. And by definition, we have definition for this: e to the y minus e to the negative y over 2. Okay, and we try to solve for y, right? So this is what? 2x equal to e to the y minus e to the negative y. Simply multiplying both sides by 2. So this is e to the negative x. So multiply both sides by e to the y. I got 2x e to the y equal to e to the y squared minus 1, because e to the y times e to the negative y is equal to 1, reciprocal. So this is e to the y squared minus 2x e to the y minus 1 equal to 0. You see this is a quadratic function with e to the y as a variable. Let u equal to e to the y. You have u squared minus 2x, u minus 1 equal to 0. Use quadratic formula. Okay, u is equal to negative b, which is 2x, plus or minus square root of b squared minus 4ac, which is 4x squared, minus 4, a is 1, c is negative, so 4 right here, all over 2. Take out a 2. Let me write somewhere here. Right up here. Okay. So u is equal to x plus or minus square root of x squared plus 1. I factor out the 4 square root. It's just 2, right? Divide by 2 on the bottom. That's what I got. And this is u means what? E to the y. So y is ln of this. But x minus square root of x squared plus 1 is negative number. You don't take it, only take positive number, right? So ln of x plus square root of x squared plus 1. And this is a proof. Okay? You do the same thing for cosine and tangent. You have the function. Just write it down somewhere on your notes, or put in your pocket. This may be helpful. Now let's talk about the derivative of the strict inverse function. Sine inverse of x, derivative is equal to, as you see, I don't remember, so I'll copy, but I'll show you how to derive it if we don't remember. That's going to be better. But as instructor, I got to write down. So 1 over square root of 1 plus x squared. This is the derivative. Okay? And cosine, hyperbolic cosine of x, inverse. Derivative is 1 over square root of x squared minus 1. Okay? Derivative tangent, hyperbolic tangent inverse of x, derivative is 1 over 1 minus x squared. I think cotangent is the same. Yes. Hyperbolic cotangent inverse of x, derivative is still 1 over 1 minus x squared. It's the same thing. Okay, 2 more, and then I'll show you how to prove the formula. All right. Secant, hyperbolic secant inverse of x, derivative is 1 over x square root of 1 minus x squared. Let me double check, make sure I got it right. Yes. And then cosecant, hyperbolic inverse x, derivative is 1 over absolute value of x square root of 1 minus x squared. Oh, x squared plus 1. All right. So let me try to prove one of the formula. Just try to prove the derivative of sine. Okay, sine inverse. The strategy is this: whenever you guys see the inverse function, you try to bring it back to our normal function, and we differentiate from there. So verify that. Y equal to hyperbolic sine inverse of x. So my job is to calculate y prime, right? Okay. The whole thing is y prime. What is that equal to? So I don't know how to work with the inverse function directly. I'll bring it back to the normal function. It means x equal to sine hyperbolic of y. This is the inverse of the original one right there. So here's the definition. Sine of y is what? E to the y minus e to the negative y over 2. That's x. Now we have implicit differentiation already. Differentiate both sides. This is 1 equal to e to the y, derivative is e to the y times y prime minus e to the negative y times negative y prime, so it becomes plus y prime again. This is over 2. Okay, so multiply both sides by 2 again, make it easy. Times 2 right here. Okay, then factor out the y prime. This is e to the y plus e to the negative y, and times y prime is equal to 2. Okay, and you solve the y prime. Y prime is 2 over e to the y plus e to the negative y. Is that right? Okay. Now we're gonna yeah. But what is this? Is it the reciprocal of is that the reciprocal of cosine? Is that right? Yeah. Yeah. We have e to the y plus e to the negative y over 2. This is cosine of y, right? So this is cosine of y, so over 2. So this is 1 over cosine of y. Is that right? 1 over cosine hyperbolic cosine of y, which is secant. And we can calculate x equal to sine y. We have what? Cosine square of y minus hyperbolic sine square of y equal to 1. Yeah. So we know this already. So this is what? Cosine square of y hyperbolic, equal to 1 plus hyperbolic sine square of y. Okay, and this is 1 plus x squared. So cosine square is this. So hyperbolic cosine of y is square root of 1 plus x squared. So this is 1 over square root of 1 plus x squared. That's it. All right. And let me stop the section right here. And this is how, to be honest with you, this is how I figure out, because I don't remember all the formulas. You see, when I try to put the formula on the board for you, I have to look at the books to get the formulas, because there's no way that I can. At least for now, I don't remember all of them. But it's a lot more important rather than memorizing all of them. I'll try to figure out a way to derive all the formulas. So as you see right here, life, that's whenever we have a function, I try to calculate and have the derivative out of it. It may take you more time to think of it, but it's gonna be, at least for me, it's easier to get it instead of trying to memorize everything. And hopefully, we have the lecture right here. It's helped you to get an idea of the hyperbolic sine and cosine. I wish if we have more in this, I think that you guys see them back in Calc 2, okay? We'll get back to Calc 2 and then we have more time to talk about this. For Calc 1, it's only one section, just introduction to hyperbolic function. And this is the basic formulas that I can give you. And again, this is mathematics, so please spend some time and practice to get the hang of the formula. And should you have any question, please don't hesitate to ask. I'm always here for help. Have a great day, guys.